Hi, welcome to another lecture in soil mechanics. So we are now already in the second chapter, which is the physical properties. This chapter includes the soil properties and their determination, the Atterberg limits, sieve analysis, hydrometer and pipette analysis, Stokes' law, and the grain size distribution. So in this video, we will be discussing the soil properties and we will be solving some example problems regarding those. And the following videos will be about the determination of the soil properties and the rest of the topics for this chapter. So, we have here the soil sample. So we all know that the soil is consisted of three phases, which are the solids, the water, and the air. And let us separate those three. So this is what it would look like if we would separate those. So we have here V as the total volume of the soil sample. And Vs is the volume of soil solids. V sub V, which is the total volume of voids. And Vv is consisted of the volume of water plus the volume of air. And on the other hand, we have the weight. We have the total weight of the soil sample as W. Notice that the weight of the air is neglected and is equated to 0 since the weight of the air is negligible as compared to the weight of the water and weight of the soil solids. And so, therefore, we have the total weight is equal to the weight of water plus the weight of soil solids. So, let us establish some mathematical equations. So, first, VV is equal to V sub A plus V sub W. And then, the total volume V is equal to V sub S plus the volume of voids, and which is also equal to Vs plus Va plus V sub W. And then, for the weight, we can write W is equal to the weight of water plus the weight of the soil solids. So we have three volume relationships, which are the void ratio, the porosity, and the degree of saturation. So first, the void ratio E. So this is the ratio of the volume of voids to the volume of soil solids. So the volume of voids can be very small as compared to the volume of soil solids or vice versa. So the range of the void ratio E can be in between 0 to infinity. And next is the porosity. So porosity is the ratio of the volume of voids to the total volume of the soil sample. And the volume of voids cannot be larger than the total volume of the soil, or it cannot be equal to the volume of the soil. So the range of the value for porosity is anywhere in between 0 and 1. Lastly, we have the degree of saturation. So this is S. And usually, this is also presented in terms of percent. So the degree of saturation is the volume of water all over the volume of void. So this indicates how much how, how much of the voids is filled up with water. So if you want to express this in percent, we will simply multiply this by 100. So the degree of saturation ranges is equal to 0 if completely dry, and S is equal to 1 or 100% if in percent if the soil is fully saturated. So we have now discussed the volume relationships. We will proceed with the weight relationships. So the first weight relationship is the moisture content or water content. So this is denoted by the small letter omega, and this is equal to the weight of water all over the weight of the soil solids, or sometimes in mass also, mass of water all over the mass of mass of solids. Next is we have the moist unit weight, which is denoted by gamma. This is equal to the total weight of the soil sample over the total volume. And for the dry unit weight, gamma sub D, this is equal to the weight of soil solids all over the total volume. So these two, if you want to express this in densities, you will use the mass instead of weight. So using those relationships that we have discussed earlier, we can form various relationships. The first is the relationship between void ratio and porosity. So let us recall that E is the volume of voids all over the volume of soil solids, and porosity N is the volume of voids all over the total volume of soil. So we can write that porosity N is equal to EV sub S all over the total volume of soil. And previously, we also know that we can write E and then Vs as the difference of the total volume minus the volume of voids all over the total volume. And to simplify this equation, we will simply multiply 1 over the total volume over 1 over the total volume. So we can write E times V over V is equal to 1. VV over V, that is equal to the porosity N. And then V over V, that is also equal to 1. And then simplify, rearranging, we can write N is equal to E times 1 minus N. Or if we want to isolate E, we can write E is equal to N all over 1 minus N. So this is the first. And if we want to isolate the porosity N, we can also write N is equal to E minus E sub N from this one. And then E is equal to N plus E sub N. So I have just rearranged it a bit, and then E is equal to N times 1 plus E, and then N is equal to E all over 1 plus E. So there you have it. We have the first two relationships. So next is the relationship among the mass of soil solids, and the moisture content. So again, let us recall, moisture content is equal to the mass of water all over the mass of soil solids, and we have the total mass of the soil, which is equal to the mass of soil solids plus the mass of water. Mass of water. We will simply equate that the mass of water is equal to this one, and then W moisture content times the mass of soil solids is equal to the total mass minus the mass of soil solids. So can we write M is equal to moisture content times mass of soil solids plus the mass of soil solids. So the total mass is equal to the mass of soil solids times 1 plus moisture content. So this moisture content should be in decimal and not in percentage. So you can also apply the same for the weight. So next is the relationship among the unit weight, the dry unit weight, and moisture content. So this is very similar to the previous relationship that we have discussed. So the moist unit weight, gamma, is equal to the total weight all over the volume. And then we have the dry unit weight, which is equal to the weight of the soil solids all over the volume. So can write total volume is equal to total volume, and then we have the weight all over the unit weight is equal to the weight of soil solids all over the dry unit weight. So we can rewrite the total weight as the weight of soil solids plus weight of water all over the unit weight, and then this will be equal to the weight of soil solids all over the dry unit weight. And we also have moisture content is equal to weight of water over the weight of soil solids. Just an additional. So we can write the weight of water in terms of weight of soil solids as omega times W sub S. So we can now express this in terms of the weight of soil solids. So W sub S plus omega times W sub S all over gamma is equal to W sub S all over the dry unit weight. So we can cancel this one, and then we are left with 1 plus omega all over all over the unit weight is equal to 1 all over the dry unit weight. And then simplifying, we can write unit weight is equal to the dry unit weight times 1 plus moisture content omega. Again, the moisture content should be in decimal. Next is the relationships among void ratio, moisture content, and specific gravity. So this is a bit tricky as compared to the other relationships that we have established, because we have to assume or consider a volume of a soil where the volume of soil solids is equal to 1. And then, if the volume of soil solids is considered as 1 unit, then the volume of voids will be equal to the void ratio E numerically. This is because, looking back, the total volume V is equal to volume of soil solids plus volume of voids. So we can write V is equal to 1 plus E. So how did we arrive with this one? So this is simply because E is equal to the volume of voids all over the volume of soil solids. And if this is assumed to be 1, E is numerically equal to the volume of voids. Next is let us express the weight of the soil solids and the weight of water in terms of the specific gravity and the unit weight of water. So we know that if we multiply the specific gravity or G sub S of the soil solids and multiply that to the unit weight of water, we can write the weight of soil solids all over the volume of soil solids. And Again, this is assumed to be equal to 1. So we can write weight of soil solids is equal to G sub S times unit weight of water. And then, for the weight of water, the moisture content is equal to the weight of water all over the weight of soil solids. So, we have weight of water is equal to omega times weight of soil solids. And again, the weight of soil solids is given by specific gravity times unit weight of water. So, the weight of water will be the moisture content times the specific gravity and then the unit weight of water. So, let us look back at the moist unit weight. So again, the moist unit weight, gamma, is given by the total weight all over the volume. And again, the weight is equal to the weight of soil solids plus the weight of water all over the total volume, which now we can write V as 1 plus E. 1. And how would we express this in terms of the moisture content, unit weight of water, and specific gravity? So we have already established those. And we will simply write weight of soil solids as G sub S, unit weight of water, plus the weight of water as